Okay, today we're going to be going over some statistics problems with expected values using Riemann sums as well as integrals. So the way that we would know to use a Riemann sum versus an integral for our expected value depends on our p of x. Since we could have x and p of x as our Riemann sum for our expected value, or the integral of x and p of x. The issue is we use the Riemann sums when we actually know what our values are. So for example, this question, we know our p of x will be 0, 0.25, 0.5, and 0.25 again. However, for the integral, we won't know what our p of x is. We're just going to know what the formula is, what the equation is. So following that, to find our expected value for the demand for the cheesecake in our question, we have to use our formula, which is our E at x is going to be the sum of x multiplied by p at x, which is going to be equal to our 0, which our p of x is 0, plus 1 multiplied by our p at x, which is 0.25, plus 2 multiplied by 0.5, plus 3 multiplied by 0.25, which will give us the expected value of 2. So now, for part B, we want to find the expected daily profit if the deli makes only one cheesecake per day. So how this will work is we know that each cheesecake costs $5 to make. So for part B, we're starting off with negative $5 because we're automatically making one cheesecake and we're selling it for $11. So if the deli does not sell the cheesecake, then the daily profit will only be negative 5. However, if the deli does sell the cheesecake, then the profit will be $11 because it says that it will sell for $11. Which means that our expected daily profit, if it only makes one cheesecake, is going to be our profit if we sell the cheesecake minus what we would have lost, which is going to be equal to 6. Another way that you could solve this would be by using our expected value formula. So we'll have our expected profit this time will be equal to the sum of our profit multiplied by our f at p, which is going to be equal to what our profit would be if we sold 0, which would be negative 5, if we sold 0, plus our profit if we sold 1, which would be 6 multiplied by 1, which is our total profit of 6. So now following this for part C, where we want the expected daily profit if the deli makes only 2 cheesecakes per day, we can find our expected profit by equaling the sum of our profits multiplied by the function of our profits. Negative 10 if we sold 0, plus, and now this is going to be 1. However, since this one's a little bit different because we could get 1 or 2 cheesecakes, there's only a 0.25 chance of that. Of selling only one cheesecake, plus 12 as our profit multiplied by 0.75, which will give us our expected profit if we only made 2 cheesecakes as 9.25. And now for part D, we need to find the moment generating function, which is going to be the m of x of t which is equal to the expected of, instead of x, it's going to be e to the tx. So this is just going to be equal to the sum of e to the tx multiplied by our function. So this is going to be equal to e to the t, and in our first case our x is 0, multiplied by p at 0, plus e to the t multiplied by 1, multiplied by p at 1, plus e to the 2 multiplied by 2, p at 2, plus e to the t at 3, t times 3, multiplied by p at 3, which is going to be equal to 1 multiplied by 0, plus 0.25 multiplied by e to the t, plus 0.5 times e to the 2t, plus 0.25 e to the 3t. And now we need to remember that our e of x squared is going to be equal to the moment generating double prime at 0. Since if we want to just find our regular expected value, we could find our moment generating function, but it's going to be the moment generating, and it's the prime at 0. So how we could do this to find our expected x squared, we're going to take our derivatives. So this will already be a 0, and now our e to the t, no matter how many times you take e to the t, the derivative of e to the t is just going to still be e to the t. So this will just be 0.25 multiplied by e to the 0, plus, and now 0.5 e to the t is going to change because when we take the derivative, it'll be 0.5 e to the 2t multiplied by t. So this will give us 1. And then since we needed to do the second derivative, this will be 1 e to the 2t multiplied by 2, which will give us 2 e to the 2. But now we need to change our t to 0. So now we need to find e 0.25 multiplied by e to the 3t, and the derivative of this will be 0.25 multiplied by 3, which will be 0.75, and now multiplying it by 3 again will get us 2.25 e to the 3 and t at 0, which will become 0.25, e to the 0 is just 1, plus 2, and then again e to the 0 is 1, plus 2.25, and e to the 0 just becomes 1, which will give us our second moment as equal to 4.5. So now our next question, as you can see, we have our f at x, and we still want to find our expected value and variance. But this time, as you can see, we are given our f at x, we're not given the values, meaning that we're going to have to use the integral. So the formula for finding our expected value is going to be equal to the integral from our bounds, which here we can see is 0 and 1, and it's going to be x multiplied by our function, which you can see is 2x multiplied by dx. So following this will just become the integral from 0 to 1 of 2x squared multiplied by dx, which will be equal to 2x cubed divided by 3 from 0 to 1. And since we'll have our upper bound minus our lower bound, this will be 2 multiplied by 1 cubed divided by 3 minus 2 multiplied by 0 cubed divided by 3. And since this is just 0 and 1 cubed is equal to 3, this satisfies our what the question wants, giving us 2 over 3 as our expected value. Now, to find the variance, we not only need the expected value, but we need the second moment. which is e of x squared, which is the same thing. It's still the integral from 0 to 1, but this time it's going to be x squared multiplied by our function, which is 2x, which will give us the integral from 0 to 1 of 2x cubed multiplied by dx, which will be equal to 2x to the 4 divided by 4 from 0 to 1. Now, putting in our bounds, this will give us 2 multiplied by 1 to the 4 divided by 4 minus again is 2 times 0 to the 4 divided by 4. And since this is 0, and this will just simplify to 1/2. Now, in order for our final step, which is finding the variance, we need to state what the formula is, which is e of x squared minus e to the x all squared. So this means that we're going to get 1/2 minus 2/3 squared, which will be equal to 1/2 minus 4 over 9, or in order to subtract getting our similar denominator, this will become 9 over 18 minus 8 over 18, which will give us again the answer we're looking for of 1 divided by 18. So therefore our expected value is equal to 2/3, and our variance is equal to 1 over 18.